Okay, 39. This is a really interesting question. How many relative extrema values does the function whose derivative is given by y prime equals sine of ln of x have in the interval 0, x less than or equal to 1? Okay, so you might be inclined to just graph this and then look at it and be like, oh, it's got 2 or 3 or something like that, and you just look at it and you say, okay. The difficulty with that is that there's some crazy behavior going on when x gets really close to 0. I'll explain that in a second. But that being said, I'm fairly certain on your calculators you have the option to just find the zeros of a graph. And in that case, you should be able to just move left and right and just toggle between, not toggle, but switch between all your zeros. And you'll be able to see, it'll look strange, but you'll be able to see that there's quite a few zeros in there, and the actual answer ends up being E, more than 4. So if you just plot this in your calculator and then do the option to find the zeros, you'll be able to see that there's actually an infinite number of zeros. I'll explain that now. So it's definitely more than 4. Your answer is E. But so if we want to understand this, we have to understand the behavior of ln of x. So ln of x looks like this, right? At y equals 0, it's 1, right? Because ln of 1 equals e to the what equals 1, well, 0, right? So it's like this, and then it looks like this, if we remember ln. And then we've got an asymptote. That means our function is getting closer and closer. As x gets closer and closer to 0, our function goes to negative infinity. Okay, well, what does this have to do with our function here? Well, I'm taking the sine of this, right? So I'm going to go through, the sine, it should have angles, and it's going to go, this is going to be equal to 0 at any time where, for instance, sine of theta equals 0 when theta equals pi times n. Or n pi, right? If theta equals 0, sine is 0. If theta equals pi, sine is 0. If theta equals 2 pi, sine is 0. If theta equals 3 pi, which means I've gone around, here's my unit circle, right? I've gone around my unit circle once, now I'm at 2 pi, okay, now I'm at 3 pi. Then 4 pi at 0, 5 pi, 6 pi. So anytime theta equals n pi, right, where n is a positive integer, I'm going to get sine of theta equals 0. Well, let's see. Where will ln of x be an integer or be a multiple of pi? That's my question. Now this also applies for negative, right? Negative pi is here, negative 2 pi is here, negative 3 pi, right? Well, my ln goes to negative infinity. Well, guess what? That means it's hitting negative pi, then it's hitting negative 2 pi, then negative 3 pi, negative 4 pi, negative 5, all the way down to infinity, right? So as it gets closer and closer to 0, right, which is in my domain, my ln is going through an infinite number of multiples of pi, which means I'm going to get the sine of negative pi, the sine of negative 2 pi, the sine of negative 3 pi, sine of negative 4 pi, all of those values, right, because ln of x is going to go through all of those values on the right-hand side in my domain from 0 to 1, which means that I've got an infinite number of times that this function this derivative is going to equal 0, right? And they're asking how many relative extrema values. Well, relative extrema means this y prime is equal to 0. That's what a relative extrema is when the derivative is equal to 0, right? So, and it's not just that. Obviously, it's where it switches from positive to negative. Relative extremas, if I've got a max or a min, and if we wanted to really go deep into it, we could understand it, we could graph it, we could plot it. But suffice it to say that the thing is that as x gets closer and closer to 0, my ln is going to negative infinity, which means I'm going to have an infinite number of zeros for this here, because it's going to go from negative pi, negative 2 pi, negative 3 pi, all the way down to negative infinity. I hope that makes sense. Like I said, you can also just plot it, put it in your calculator. I'm not exactly sure how it's going to come out because I don't have your calculator, but you should be able to see that you're going to have more than 4 zeros if you just kind of zoom in and like look closer and things like that. So you should be able to just do it on your calculator, but conceptually this is why it's got an infinite number of zeros. So it's a kind of a cool question. I hope you understood it, and I'll see you in the next video.